Inflammation. It's a word we often associate with pain, swelling, and redness, typically after an injury. Imagine twisting your ankle. The area becomes tender, inflamed, a sign your body is working hard to heal itself. This natural process is called acute inflammation, and it's our body's first line of defense against harm. Now, imagine this inflammatory response going into overdrive, lingering for weeks, months, or even years. This persistent state of inflammation, known as chronic inflammation, is where the real trouble begins. Unlike its acute counterpart, chronic inflammation doesn't heal. It slowly damages tissues and organs, setting the stage for various health problems. But what happens when this inflammatory process takes hold within the intricate network of our brain? That's when we enter the realm of neuroinflammation. Neuroinflammation, simply put, is inflammation occurring within the brain or central nervous system. Like inflammation elsewhere in the body, it can be beneficial in small doses, helping to clear out damaged cells and pathogens. However, when neuroinflammation becomes chronic, it can have profound consequences for our brain health and overall well-being. Our brains are incredibly complex organs, orchestrating everything from our thoughts and emotions to our movements and bodily functions. To protect this vital organ, a protective barrier, known as the blood-brain barrier, exists, tightly regulating what can enter and exit the brain. However, under certain circumstances, this barrier can become compromised, allowing inflammatory molecules to slip through and trigger an inflammatory response within the brain. This breach can be caused by a variety of factors, from infections and autoimmune disorders to lifestyle choices and environmental toxins. Once inside, these inflammatory agents wreak havoc on the delicate balance of the brain, disrupting communication between neurons, impairing cognitive function, and even leading to the death of brain cells. This chronic, low-grade inflammation within the brain is what we refer to as chronic neuroinflammation. Chronic neuroinflammation doesn't happen overnight. It's often a gradual process, silently brewing over time, its effects slowly becoming apparent. Understanding what causes this shift from protective to destructive inflammation is crucial in tackling this complex condition. Why does neuroinflammation become chronic in the first place? The answer lies in a complex interplay of factors, some within our control, others not. One major contributor is our genetic makeup. Certain genes can predispose individuals to developing chronic inflammatory conditions, including those affecting the brain. Lifestyle plays a significant role as well. Poor diet, lack of exercise, chronic stress, and inadequate sleep can all contribute to a state of chronic inflammation throughout the body, including the brain. These factors disrupt the delicate balance of our immune system, making it more likely to overreact and trigger inflammation. Beyond our individual habits, external factors also contribute to the problem. Exposure to environmental toxins, heavy metals, and pollutants can damage the blood-brain barrier, allowing inflammatory molecules to enter the brain. Additionally, certain infections, both viral and bacterial, can trigger an inflammatory response within the brain, sometimes leading to long-term consequences. Understanding these triggers is crucial for prevention and treatment, empowering individuals to make informed choices about their health and minimize their risk of developing chronic neuroinflammation. The brain is a highly interconnected organ, with different regions communicating constantly to regulate our thoughts, emotions, and actions. Chronic neuroinflammation disrupts this intricate communication network, leading to a cascade of effects on brain function. One of the primary targets of neuroinflammation is a type of brain cell called microglia. These cells act as the brain's immune cells, responsible for clearing out damaged cells and debris. However, when constantly activated by inflammation, microglia can become overzealous, attacking healthy brain cells and contributing to further damage. This chronic inflammation also disrupts the production and function of neurotransmitters, chemical messengers that facilitate communication between neurons. This disruption can manifest in a variety of ways, from mood disorders like anxiety and depression to cognitive impairments like brain fog and memory problems. Moreover, chronic neuroinflammation is increasingly being recognized as a key player in the development of neurodegenerative diseases like Alzheimer's and Parkinson's. While the exact mechanisms are still being investigated, it's believed that the persistent inflammation contributes to the progressive loss of brain cells characteristic of these debilitating conditions. Section 5. Beyond the brain, the ripple effects of neuroinflammation. While neuroinflammation primarily affects the brain, its impact extends far beyond, influencing various bodily functions and overall health. This interconnectedness stems from the brain's role as the command center of the body, constantly communicating with and regulating other organs and systems. One area significantly impacted by neuroinflammation is the gut. Emerging research highlights a powerful connection between the brain and the gut, known as the gut-brain axis. This bidirectional communication pathway involves the nervous system, immune system, and microbiome, the trillions of bacteria residing in our gut. Chronic neuroinflammation can disrupt this delicate balance, leading to gut dysbiosis, an imbalance in the gut microbiome. This imbalance can manifest as digestive issues, such as bloating, constipation, and irritable bowel syndrome, or IBS. Moreover, gut dysbiosis itself can further fuel neuroinflammation, creating a vicious cycle. Beyond the gut, chronic neuroinflammation has been linked to a range of systemic health issues, including cardiovascular disease, type 2 diabetes, and autoimmune disorders. This highlights the importance of addressing neuroinflammation not just as a brain-specific issue, but as a systemic problem with far-reaching consequences. Section 6. Recognizing the signs. Symptoms of chronic neuroinflammation. Chronic neuroinflammation often presents with a constellation of symptoms, varying in severity and presentation from person to person. This often makes diagnosis challenging, as these symptoms can mimic other conditions and are often attributed to stress, aging, or other factors. One of the hallmark signs of chronic neuroinflammation is cognitive dysfunction. This can manifest as brain fog, difficulty concentrating, memory problems, and slowed processing speed. Individuals may find it challenging to focus on tasks, remember appointments, or learn new information. Mood disorders are also common, with many individuals experiencing increased anxiety, depression, irritability, and mood swings. These mood changes can significantly impact daily life, relationships, and overall well-being. Other common symptoms include fatigue, sleep disturbances, headaches, and chronic pain. These symptoms can be persistent and debilitating, making it challenging to engage in daily activities and maintain a good quality of life. Section 7. A multifaceted approach: diagnosis and treatment strategies. Diagnosing chronic neuroinflammation can be complex, as there is no single test to confirm its presence. Doctors rely on a combination of methods, including a thorough medical history, physical examination, and assessment of cognitive function and mood. Blood tests can detect markers of inflammation, while brain imaging techniques such as MRI can reveal structural or functional changes in the brain suggestive of neuroinflammation. However, it's important to note that these tests are not always conclusive and require careful interpretation in the context of an individual's overall health and medical history. Treatment for chronic neuroinflammation typically involves a multifaceted approach, addressing both the underlying causes and the symptoms. Lifestyle modifications play a crucial role, with a focus on reducing inflammation through diet, exercise, stress management, and sleep hygiene. Medications may be prescribed to manage specific symptoms, such as antidepressants for mood disorders or nonsteroidal anti-inflammatory drugs, or NSAIDs for pain and inflammation. In some cases, stronger immunosuppressant medications may be necessary to suppress the overactive immune response driving neuroinflammation. Section 8. Lifestyle interventions. Empowering your brain health. While seeking professional medical advice is crucial, individuals can take proactive steps to manage and improve their brain health through lifestyle modifications. These interventions focus on reducing inflammation, supporting brain function, and promoting overall well-being. Diet plays a vital role in managing inflammation.